Okay, 11.2, we're still talking about arcs and chords. This is the second part. I split this video up into two because it's a lot of information. I just want to review what a central angle and what an arc is. A central angle, if you have a circle, that's a beautiful circle, I know. If you have a circle, the arc is the outer part of the circle. So would be considered an arc. If I wanted to go from this point to this point, this is considered an arc. And it's unbroken, so I can't say that this and this is one arc. This is the only, this would be considered an arc. It's unbroken. And how it's formed, again, is by 2 points, or you can think of it as a radius connecting these two arcs. This is one way you can think of an arc. When we have a radius, so this is a radius, meaning it goes from the outer part of the circle into the center. So this is a radius. And this is a radius. When two radii form, what happens in the middle, this part right here is called the central angle. And the relationship between the central angle and the arc is that they're always congruent. So the central angle is congruent to the arc measure, the measure of the arc. And when we're talking about measures of arcs, central angles are going to be in degrees, and the measures of the arcs are also going to be in degrees as well. So they're both going to be measured in terms of degrees. I don't know if we went over this last time, but adjacent arcs, well, we know adjacent means right next to. So adjacent arcs means arcs that are right next to each other. And that's going to be important for what we're doing today. So we've already taken notes on this part. In example 3, applying congruent arcs and chords. Well, the relationship between angles, central angles, and arcs, we know that these are congruent to each other. So these are going to be congruent to each other. That's what we just talked about. The other thing that's really cool is that the chords in between those things are also going to be congruent to each other. So what that means is this. I'm going to zoom this in really fast so I can have a blank space. You don't have to draw this down. You don't have to write anything down unless you really, really want to. But, all right, I think that's pretty zoomed in. Okay, when we have two congruent circles, so here's a circle and here's a circle, and I'm telling you that these circles are going to be congruent to each other. Okay, let's say there's the centers of my circles. Let's say I have two radii, and remember, in between these two radii are angles, and let's say that these angles are going to be congruent to each other. Well, two things happen. If the central angles are congruent, that means that the arcs are going to be congruent. So that means, that these arcs are going to be congruent to each other. And that means that the chords are going to be congruent to each other. So what I mean by chord is if I connect this point right here to this point right here where the two radii meet the arc, that's going to create a chord. Remember, a chord is just a line segment that has two ends, meets 2 times on the circle. So if I connect that point to that point, and same over here, well, those two chords are also going to be the same segment length. So this is going to be congruent to this. So 3 really awesome things happen. It's important to take note of. So what you're going to do tonight on your homework, oops, it's a little bit too much, is you're going to see some pictures that look like this. Oops. All right, there we go. Okay. That look like these 4 different pictures. So for 13, if you notice, we have congruent arcs. Chords. These are line segments, and they meet once, twice on the circle, and once, twice on the circle. So sometimes that can happen within one circle, or if we have 2 congruent circles like we do in number 14. So if we are just talking about one circle and we have 2 congruent chords, then that's going to mean that these arcs are also going to be congruent to each other. So if I wanted to find out what the measure of arc WS is, I want to figure out how long this arc is. Well, all I have to do is set these two things equal to each other. So 9n minus 11 equals 7n plus 11. I'm going to move the n's over. I'm going to add this 11. So now I'm going to get that 2n equals 22. I'm going to divide both sides by 2, and I'm going to get n equals 11. And I'm not done. We're not going to stop here. We're going to go back and read the question. It says find measure of arc WS. So I'm going to plug this in here because that's WS. And 7 times 11 is 77 plus 11. We have 88 degrees. Remember, we were talking about arc measures or angle measures. Our answers are in degrees. Okay, so this is an example of having two congruent chords within one circle. Here's an example of having two congruent circles. They tell us that right here. We have two congruent circles, and they tell us that these central angles are congruent to each other. So what that means is that the segment lengths, these chords, are going to be congruent to each other as well. Now, chords are lengths. These are segment lengths. So our answer will not be in degrees. So we have 14t minus 26 equals 5t plus 1. These two things are congruent to each other. I'm going to subtract the 5t, and I'm going to add a 26 to get everything onto its respective sides. And I'm going to end up that 9t equals 27. If you divide by 9, you get t equals 3. And now we're almost done. We're going to go back and plug it in because we want to find out how long this segment is. So 5 times 3 is 15, plus 1 is 16. And that's how long that segment is. It's not in degrees. Only central angles and arc and measures of arcs are in degrees. Okay, so I'm going to do one more, and then I'll do this one for you guys, and then you're going to do number 15. And I'm going to check it in class. Okay, so 16 says PT bisects angle RPS, and that's so important because bisects means that it's going to cut this angle into two congruent pieces. So now we have one circle with two congruent central angles. So that means that the arcs are going to be congruent, and that means that the chords are going to be congruent. Two awesome things happen. So they want us to find RT. That's a chord. That is not an arc. But it doesn't really matter. We know that RT is 6x, and we know that ST is 20 minus x, so all we have to do is set those equal to each other. I'm going to add a 4x over here and get 10x equals 20, and then divide, and I get x equals 2, and then I'm going to plug it in. And it doesn't matter which one I plug it into, right, because they're both the same. I think 6x is pretty easy to plug into, so 6 times 2 equals 12. Okay, so you guys are doing 15 and answering reflection number 2. And the other thing we're going to learn tonight are talking about radii and chords. So something really awesome happens when we have a radius or a diameter hitting a chord. If it's perpendicular, if a radius or diameter, doesn't matter, either one, is perpendicular to a chord. Perpendicular means hits at 90 degrees. Then it's going to bisect the chord. And bisect means cut it in half. All right, that's what this thing says. If we have a radius, CD, and it's perpendicular to this chord, EF, that means that this segment has to be congruent to this segment. And the opposite is true as well. If you have a chord, I'll call this chord number 1, and it bisects a second chord perpendicularly, so it meets at right angle and it bisects it. It's perpendicular bisector. That means that chord number 1 is either a radius or diameter. Okay, so really quickly, 17 and 18, these are the last two problems. I'm going to do number 17, and you're going to do number 18. Okay, so find NP. Oops, I don't want all this stuff. Whoops, sorry. Okay, number 17 says find NP. This is a chord. If you look at NP, this is a chord. So just something to take note of. If you notice RM, that's the radius. So the first thing you want to look for, if you can, is find out how long the radius is. So I know that this part's 8 and this part's 9, so 8 plus 9 is 17. So the radius is 17. That's important. The second thing I want you to do is, again, we're trying to figure out how long this chord is. So the second thing I want you to do is to draw another radius, because we know that all radii in one circle are going to be congruent. So what happens if I draw a radius like this? Well, now we have a right triangle. And I know that this part's 8 and this is a radius. So that means this radius also has to be 17. That's what we found out in the beginning. So the last thing you're going to do is do Pythagorean's theorem. And that's going to tell us how long ns is, how long this is, x. So 8 squared plus x squared equals 17 squared. And you're going to find out that x will come out to be 15. And you're so close to being done, because if this part is 15, that means that this part also has to be 15, since they're congruent to each other, because the radius is perpendicular to it. So 15 times 2, our final answer is NP equals 30. Okay, so the first thing we did was found out how long the radius is. Second thing we did was drew it. Third thing we did was Pythagorean theorem, and then the fourth thing we did was double it. So try that for number 18, and then you are all done learning about arcs and chords.